Completing the square is a method of factorization for quadratics, which puts quadratics into this form here, where you have x plus a all squared plus b, where a and b are numbers. And this particular form is for quadratics which have the form ax squared plus bx plus c, where a is equal to 1. So this is a prime example here. We have 1x squared, so basically it's just x squared, minus 4x plus 16. So these types of quadratic, which are sort of the easier ones, if you like, compared to the ones where a is greater than 1, go into a completed square form like that. So I'm going to run through the rule of how to do this, and it's very straightforward. Let's write out the rule first of all that I'm going to use to carry out this factorization. So I'll just write it in sort of normal language that you can understand, so that you can just apply it and get the correct answer. So what you have to do is you have to half the middle number. The middle number, by the way, is that one, b, and put into the first bracket all squared. So that's the first thing you have to do, is you have to half the middle number and then put into the first bracket all squared. So that's this bit. And then in the second part, you have to expand the bracket. Once you've expanded the bracket, look at the value of C generated. So look at the value of C generated and then add or subtract to produce B. When I say B in this case, I mean if I underline, as in this value there, B there. Not this original B, but the one in the completed form. So let's go ahead and do that. Our middle number here is 4. And by the way, you ignore the sign, just leave that as a minus. So in the bracket, instead of having a plus, you would put it as a minus. Just take the number, apply the rule to the number as if it were positive. So half of 4 is 2. So that is going to be our value of A. So we have bracket x minus 2 all squared plus 16. Right. Now, this bracketed term here is this part here. Now we have to expand that. So let's write it out fully. So this is what we're expanding. So we have x squared minus 2x minus another 2x, and then minus times a minus makes plus 4. So we've got x squared minus 4x plus 4. So the last thing to do is to find this value of b. So now that I've expanded this expression, I have a new value of c, which is this part I was referring to here. And that value of c, you can see, is positive 4. I've just put a box around it. It's just positive 4. So I have positive 4. So think about this. What do I need to do to positive 4 to get back to 16? What do I need to add or subtract? To make 16, which is what it is in the original expression, I need to add 12. So if I just highlight that with a different color. So to make this work, I need to add on a 12, because 12 plus 4 would make 16, which is what that is there. So therefore, my final answer will be, just write it here, try and keep it all on the same page before we look at the next one, is going to be x minus 2, close bracket, squared, plus 12. So A is therefore going to be minus 2, and B will be positive 12. Now, if you're thinking, why is this the correct answer? How does this work? Well, we've just seen what happens when we expand that. If I expand that double bracket, I get this expression, but it only produces 4. And the original quadratic has 16, so we're 12 short. So this is why I need to add 12 on at the end to get that up to 16. So before we look at the next example, let's just recap. What have I done? I halved the middle number, the original b value then in the general expression for a quadratic. And then I've expanded the bracket out. And then I've looked at the c term generated, this last one there, which is what I was referring to here. And then I decide, do I need to add or subtract the number to get back to this original value in the quadratic? Middle number is 9. So half of 9 is going to be 4.5. So we have x plus 4.5 all squared. And remember, we need to generate minus 5. But before we do that, let's go ahead and expand this out. So what is this going to look like? So that is the value of c we have this time. But we want to make negative 5. Think about it. Do we need to add or subtract to get to negative 5? Well, the answer is we've got to take away the correct number to get to negative 5, because negative 5 is a lot less than 20.5. So we need to take away 20.5 to get back to 0, another 5 on top. To make this work, I need to minus 25.25. The final answer will be x plus 4.5 all squared minus 25.25. So we know expanding that gives us this bit, and then taking away that 25.25 gets us back to minus 5, which is from the original quadratic. So for this particular example, a would be positive 4.5 if we're using this notation, a, b integers, and then b is the number outside, negative 25.25. In the next video, we're going to look at a quadratic where, for example, you've got a number for a greater than 1, so say 5, for example, plus 10x plus, say, 17, and how this particular type of quadratic is factorized using completing the square. And it's quite similar to that, except you actually have a third number. So that becomes something where you have a, you have a term inside b, and like before, something on the outside c. So there's actually 3 numbers to determine a, b, c, making it slightly more difficult than this one where there's just 2. Link for that video is in the description below. I'll see you in the next one.